I think enough people have joined, so let's start. So hello everyone to the fourth session of CodeCrafts. So today we'll be covering OOPS and operator overloading. So this is our agenda for today. Overview on OOPS, function overloading and operator overloading. So when programming started,
I think your screen is not shared.
is it shared now? Is my screen visible?
To sharing just blank, so it's not
Okay.
visible.
Is my screen visible now?
No, it's not visible.
Okay. I'll try it once again. What about now?
It's not visible.
Okay then. Shreyas, can you please present?
Yeah, one sec.
So let's start again. Hello everyone. This is our fourth session of CodeCrafts. So today we'll be covering OOPS and overloading. Next slide. So this is our today's agenda. Overview on OOPS, function overloading and operator overloading. Next slide. So when programming started, there were mainly two ways of writing code. One was procedure oriented programming and one was object oriented. So in procedure oriented was writing functions and other code in direct flow of logic. But then programmers realized that it was not really useful and code could not be used. For example, if you had to do one task two times, so we had to write the same code twice. So they switched on to object oriented programming. So object-oriented programming is a programming style structured around objects rather than functions and logic. So with OOPS, there came four main concepts which helped programmers a lot, which would be encapsulation, inheritance, polymorphism, and abstraction, which made the code reusable, enabled data hiding, and in general helped programmers code. Next slide. So first we'll cover abstraction. So abstraction is the concept of displaying essential information and hiding the details. So when someone writes the code, there are really intricate details in code, like the algorithm and stuff, and a user need not know the stuff. So the programmer decides to hide some information from the user and display only the essential stuff. It helps in keeping the code simple. So here you can read there are two types of abstraction. One was access specifiers. Remember, in last class, we learned that there were three types of access specifier: public, private, and protected. In public, everything was visible to the programmer and user. In private, it was visible only to the programmer, but not to the user. And protected. Protected has some different properties which we'll cover in the coming classes. Then there is one more way of abstraction using header files. You guys must have wondered what is this hash include IOStream which we write in the first line. So it is a header file which gives us really useful functions. So we do not need to know how those functions work. We just need to know what they do and what the input is. So it helps keeping a code simple, and we can really use what we want without diving into the depths of it. So it's really helpful for beginners, and that's why it was implemented in object-oriented programming. Next slide. So here is an example of abstraction. This car is a Chevrolet Corvette Stingray. Uh, Just so you know. So in a car, we need to know that there is an acceleration button, then a brake. So when we press the accelerator, the car should go forward, the speed should increase, and when we reach our destination, we should brake. So this is a really basic overview on what a car does. And we do not really need to know how the engine works or how the engine is connected to the wheels, and lots of details. There may be really millions of details in the car which we don't need to know. We just need to know a few of the basic stuff. So abstraction really helps us in this way. uh, and here you can read this. Then we can also think that every device we use, for example a microwave, a phone, or even the laptop which you are using to watch the session, has some level of abstraction. There are hundreds of complicated processes going on inside which you do not know and which you need not know. That's the main point of abstraction. Next slide. So this is one more important concept: encapsulation. It is the act of combining all your data into a single unit and presenting it. So remember, we have classes and objects. So class is kind of an encapsulation of various data members and member functions which help you achieve some functionality. And it's very easy to reuse the class and objects. So if you have some similar work for a given class, so you can just create a different object and have it do the work for you. And here you can read on the slide for a minute. So I've tried to show a simple technique of data hiding. So there are maybe in some data members which are private to the class, but you need to communicate it to different classes to achieve some function maybe. So then you can just define public function which says get a. So here we have a private integer int a, and we have a public function get a. So whenever a different object of a completely different class or some different code requests for this variable, we can just use the get a function which returns the value of the variable without actually returning the variable itself. So the user can read what information is there in the variable but cannot really change it. So imagine how it improves the security of a code. So next slide, please. Then the third concept is polymorphism, which we are going to study in detail today. So polymorphism is the property of an operation to exhibit different behavior in different situations. Ignoring the complex jargon, polymorphism basically means to do different tasks by something of the same name. So for example, here this is some arbitrary code. This is not even code, but just an example. If we have a function known as make sound, and we have different animals, so we can call it, for example, say them different classes. One would be cow and one would be cat. So the same function based on different input can give me different outputs. So in the case of cow, it would be a moo, and in the case of a cat, it would be a meow. So polymorphism is implemented in C++ with overloading. So overloading is the essential act of giving different functionalities to the same function or operator having the same name, but which distinguishes the different input and gives different output on the same. So next slide. So now we'll do function overloading in some detail. So to make different you have different use of the same name function, we need to tell the compiler that uh, although the name is same, the functions entirely are different. So the way to tell the compiler is having difference in the argument list. So the first difference in argument list is the number of arguments. So as you can see in the example shown, there are two types of sum. One which has two arguments, two integer arguments, and the other which has three integer arguments. So when we in the int main we call the sum, so it reads into the argument list. It checks if there are two or three. If there are two, it will call the first function, and if there are three, it will call the second function. This way the compiler knows which function we intend to use. One more thing is that although if the number of arguments are same, if we change the data type of the arguments, then we can still achieve overloading. So for that, I was going to do a live coding example. Just next slide. I think I think that's not possible. So Shreyas, can you please try to open JDoodle? Sorry for the technical issues, guys. Just wait a few minutes. If you have any doubts until now, you can just ask them. Okay, cool. So is the code visible? Or
Was my screen visible?
yeah, I guess the screen is visible. Is the font size okay? Anyway, because zoom in a bit. Is it okay now? Because go on the code web page only. No need to switch back. I guess this is visible now. Cool. So the live code now I was trying to overload the function calculate. So in calculate, we just return the product of two integers or one integer and one float. If you have any doubts, just type it on Slido or if the of MS Teams chat if it is visible to you. Because just include some cout statement which says it's me or me there, which signifies which function is being called. Not there in the function definition, like in calc. Okay, cool. S- Because just change the float to double, because by default the floating point number is read as double. Perfect. So thank you, Vikas. Can you scroll above? So let's go through the code line by line. So the second line, it's the header file, which I explained earlier, gives us some cool functions to use without us knowing the implementation. Then there is a line using namespace std. You can ignore it for now. It lets us use cout statements like cout and cn. Now comes the most important part, the functions, overloaded functions. As you can see on line 6, 11, and 16, the calc function has the same name, all and but it has the different parameter list. First one has int a, int b, the second one has one int and one double, and the third one has two doubles. Now there was a doubt in the chat that what if I have the parameters list same and the return type different? So no, it does not work. The compiler will give an error that ambiguity is there in function definition. So we must have some different parameter list. Now, as you can see, we tried giving some input in int main to the function and we saw the output. So when we sent in two integers, so Vikas, can you scroll a bit? Perfect. So when we sent in two integers in the function calc, so the compiler automatically redirected us to the line 6 and the first calc function was called. So as you can see in the output, first there is an a printed, then by the slash n there is a new line and the product is there with 3 into 4 is 12. Now in the second cout statement on line 23, we decide to send in one integer and one double. So it prints B. So the compiler redirects it to the line 11 after looking at the parameter list and it prints B and the product of 3 and 4.3. Now similarly, in the third statement, there are two doubles as the parameter list and the compiler reads and redirects us to the line 16, which is the third calc function, and returns their product. As you can see, this works and this provides us with really cool functionalities, because when you actually program, when you actually start to code which is useful in the corporate world or anywhere, it's there are many functionalities which have the same name. So like product, if you see product, we have the product to multiply with really different things. Furthermore, you will see that you can even use the same product for objects of classes. So we'll come to that later on. So can we switch back to the slides, please? I guess it will be really clear. Perfect. So next slide. So this is the main thing which we are going to learn today, operator overloading. Let's begin. Next slide. Perfect. So I've decided to try on a simple example. Let's say we have a counter class whose objects have a single variable named count. So I will try to explain the code on the left. So as you can see, we have a class with the name counter. It has some public member functions and so a private variable. So the private variable is count, and in the public we have two constructors. So as you can see, the constructors, we have done function overloading with counter. First one takes no argument and the second one takes one argument. And then we have the get count as we saw in encapsulation. So which will return the value count. And now on the right hand side, we see int main. So which has three counter objects defined. So when the first two definitions like C1 and C2 will call the constructor, the second constructor, which takes int C as its argument. And the third C3 will call the first constructor, which takes no argument. So if we try to look at the count variable in all the three objects like C1, C2, and C3. So in C1, the count variable will have value 3. In C2, it will have value 4. And in C3, it will have value 0. Perfect. So now what we want to do is we want to add the two counts C1 and C2 and get the result. So next slide. So here is a QR. Now I'll just make the poll live. Oh, it's live. So I request you to scan the QR, it's the Slido QR, and answer in the poll. The Slido link is shared on WhatsApp with the meeting link. Because can you shift to the slides for some time? Okay, cool. Never mind. We have the Slido link here. Can you show the code for some time, Vikas, please? I'll wait for a minute more. Okay, now we'll stop the poll and we'll get back to the slides. So if you try to run this code, you will see that it will not work. The compiler will throw errors. So now we need to overload the plus operator so that it works on the user defined data types. So let me just explain it a bit. The data types int, float, everything are primitive data types. So the operation like plus, minus, product and division, they are defined for them by the compiler itself. but it is not the case for user-defined data types, which are structs or classes. So for objects of a class, we need to overload the operators so that we can achieve the same functionality for our classes as well. So next slide, please. So I've given the code which we'll need to add so that the plus operator works for our case as well. So I'll just explain it line by line. In the first line, as you can see, we need the output as a counter object. C3 here is a counter object. So the return type of the function would be counter. So one more thing, like overloading an operator, we need to overload it as a function. So here we will follow the normal function definition. So the return type is counter. Then we have the operator keyword, which tells the compiler that we intend to overload. Then the operator itself. And in the bracket, there is an argument list. As you can see, we have two operands on the right hand side of the code, C1 and C2. But in the argument list, there is only one. So since the function we would be defined inside the class, the first object we need not mention in the argument list because it will be the object on which the function acts upon. So here in this case, the counter C, it is really for the C2 object. The C2 will go in place of the argument C. Then we look at the function body. So we define a temporary counter object, and in the temporary variables count, sorry, the temporary objects data member, which is count, we will store the addition, we will do the addition manually. Count plus c dot count. So the count in green, we can use it directly because it is the count of the C1 object, the object on which the function is acting upon. And the C, like the C2. So we need to explicitly use the count of C2. And then we return this object. So what happens when we call C3 equal to C1 plus C2? So C1 is directly inputted in the function. C2 goes through the parameter list, the operation happens, and the temporary counter object which is returned, it goes into C3. So the count data member of C3 will contain the addition of count and the C1's count data member and C2's count data member. Okay, so we'll switch on to the next slide. So this is the general syntax for overloading any operators inside the class definition. Since we are overloading inside the class definition, we can access the count variable by the dot operator as it is inside the class only. And as you know, we can access the private data members only inside the class. So what if there is a need to overload some operator outside the class? So we'll look at it now. Next slide, please. So here are some more details which we'll try to cover in the next few slides of overloading outside the class definitions. So the basic functions, the syntax stays same, the return type, then operator keyword and OP. OP will be replaced by the operator which we need to overload. And here is the argument list. Now, since it is outside class definition and we don't really have an object on which the function acts upon, we need to mention both the objects in the parameter list as it is given in the green box. So next slide, please. So here is some code. You can scan the QR. It's really the same Slido link which we used previously. Because stay on the screen, don't switch to the CodeCrafts. Slido. I'll just explain the code in short. So on the left hand side, we have a class num, which is really similar to the counter class. So there is nothing to explain here. In the second code block, we are overloading the operator slash. So it is the division operator and it returns the quotient on dividing two numbers. So in the so the return type is of as the object of the class num, and in the function body we have the definition. So we this is the different way of doing the same thing which we did for the counter. So we define an integer n and store the division in them, and now return an object which is named temp. So in the second line of function body, we create a temporary object in which we pass n as the in the constructor to be stored in num, and we return this object. And in the third code block, we have three objects, and we intend to store the division of values of the num values of n1 and n2 in n3, and we print. Note that we used n3 dot get num because we are outside the class definition, and and the num is the private data member. So we can't really output and like have a statement like cout n3 dot num. We have to call the function which returns num. Okay, I'll try to explain the code in short. So on the left hand side, we had the function which is really similar to the counter class. Sorry, the class which is similar to the counter class. In the middle, we overloaded the division operator, and it is the relevant code. And on the right hand side, we called the overloaded operator to work on our user defined num class, and we try to get the output. I think it was enough time because can you just switch to the poll and end it once? So we can see that 72% have answered yes and others have answered no. So this was a kind of a tricky question whose answer would be no. So no is right. Let's see how. Next slide. Cool. So as we decided earlier, the operate overloaded operator should be outside the class definition. So we can't really use the n1.num and n2.num because they are private data members. And the compiler will give an error whenever the function is called. So whenever the operator is called from outside. So the correct code is shown on the next slide. Perfect. So the code on the left hand side and right hand side stays the same. What the changes are in the middle code. So on the first line of function body, we have used the n1.getNum and n2.getNum so that we get the value of the private variable num without actually using the num. And now this code will work. Okay, then we'll switch on to the next slide. So here we are adding the rules what we need to take care of while overloading outside class definitions. So the first one was argument list. Now the argument list should contain both the parameters, and the second one is the access of variables must be taken care of, like whether they are public or private. Can we switch on to the next slide? Now we dive into something little more complicated. Now, what if from outside we try to overload the operator for different data types? So, for example, now here in this code as well, the left side and right side almost stay the same. Only change occurs in the middle code. So the first operator, so we overload the multiplication operator, and then the return type is the object of the class num. So in the parameter list, the first one is an object of the class num and the second one is an integer. In the function definition, we have used n1.getNum to avoid any problems caused by the private access of the num variable. And you can scan the QR and vote. So answering a few queries on the chat, the attendance link will be shared in like 5 to 10 minutes. We are really near the end of the slides. I think we can stop the poll because just switch on to the Slido for a minute. Perfect. So in this time, the correct answer is error itself. So I'll explain you how. In maths, you would have read about a property known as commutativity. For an operation, does one operation 2 equal to 2 operation 1? So the operator multiplication in this case should be commutative by logic, by common logic. When we multiply 1 into 2, it is same as 2 into 1. But to show that in code, we have to do something else. So here in this case, what we have done is we have fixed that the first operator was of the type of class num and the second of was a normal integer. So when we run n1 into n2 in the code, there was no problem. So I'll just because switch to the next slide. Perfect. So most of the code is similar. However, in the second code block, I've added another operator overloaded operator definition. So I'll explain the whole code once again. So in the left side, there was a class num which had private integer and private data members integer and two constructors of the same name, overloaded constructors, and a get num. On the right hand side, we define an object of the class num and a simple integer n2, and we intend to store its products both ways, n1 into n2 and n2 into n1, into two objects of the num class, which would be n3 and n4. And when we call the operator, it directs us to the second code snippet. So now you can see most of the code is same. However, the parameter list in the first definition, the parameter list has the first uh, parameter as object of class num and the second would be integer, while in the second definition the first is an integer and the second is of the num class. And subsequently we have to modify the first line of the function body slightly, because in the first case n1 is the object, so we need to use the get num to access the value in the num variable, and n2 would be an integer. And in the second definition, n1 would be a normal integer and n2 would need accessing by get num. And we return uh, an object, a temp. So as there was a doubt, the n it would really cease to exist after the function block is over, and we don't really care about it. We only care about the object return, which is temp. So by doing this, we achieve commutativity. So whenever you try to overload for two different data types, you need to have the similar definition two times, which ensures that 1 into 2 and 2 into 1 will give the same result. And yes, the correct output would be 500, 500. Next slide. So here I've added one more rule to the green block, the things which we have to take care of while overloading outside class definitions. Next slide. So with this comes to an end of this session, and now we'll do a quick recap. So first we learned OOPS. What is OOPS? And the four main concepts, which would be data abstraction, encapsulation, polymorphism. Polymorphism is what we studied in this session, and inheritance. Inheritance is the fourth one, which we'll study in the upcoming sessions. Then we saw two types of overloading. One would be function overloading, and one would be operator overloading. And in function overloading, we saw that to distinguish between two functions of the same name, we needed to have a different parameter list. So that parameter list would be different with respect to the number of parameters, or if the number of parameters was same, the data type of at least one parameter should be different. Then we switched on to operator overloading. We saw how to use operator overloading inside a class definition when we need not worried about the access specifiers of the variables involved. Then we saw operator overloading outside class definitions. There we had additional things to worry about, like the access of variables and about commutativity in case of different data types to be used to overload a single operation. So here are the links of the attendance and feedback form. So I request you to fill the feedback form, please. Also on Slido, we have a uh, rating poll. So I would request you to please switch on, go to your Slido and rate the session. Because you may switch to the Slido for the rating poll. We'll be having the meet on for some 10 to 15 minutes more. If you have any doubts, you can just shoot them in the meet chat or on the Slido. I'll be answering doubts on Slido now. So I'll recap once again why access is not a problem if overloading is done inside the class definition. If we do the overloading of an operator inside the class definition, we are actually inside the class definition where we are permitted by the private access specifier to use the private data members of the class itself. So now the changes from, like, the differences between inside and outside would be, for inside, one object is the object on which we are calling the function, and so we need not mention in the parameter list, first thing. And second thing, the variables, it's like the, in the encapsulated, like it's between in the one single unit of the class, so we need not use the get count, so get num function, and we can directly use the private data member itself. So one doubt is, why do we need to do operator overloading? Now you yourself see how, like, if you want to do the sum for around hundreds of objects, so will you be able to write n1 dot get num and n2 dot get num every time? It's so convenient to directly write n3 is equal to n1 plus n2 with a few additional lines of code, which are the overloaded operator definition. This really decreases the amount of effort you put in to write the code. I'll, I'll explain the operator syntax once more without the slide. So the function definition line, the first line, the prototype, it would have return type first, then the operator keyword, which tells the compiler that I intend to overload the operator for my own data type, which is a class, which is known as user defined data type, and then the operator itself. So now, till now, what we have is, suppose we want to overload on a class sample, and we need the return type to be object of sample. So sample operator plus, and then in bracket we mention the parameter list. So the parameter list may contain one or two arguments based on whether it is inside the class definition or outside, and then the function body. So the function body, in the function body, you have to check how you really go to the sample object which you return in the last line. You need to take care of the access of variables. So that's basically the syntax. Okay, then we'll be ending the meet. Thank you for attending. If you have any doubts, you can just DM any of the admins on the CodeCrafts group. Thank you.